More and more, we're playing out our lives not in ordinary space, but in cyberspace. What this is MediaLab's Tangible Media Group. And what they do here is come up with new and revolutionary ways for us to interact with our computers. Take these musical bottles.
Yes, please go ahead, next one.
Okay, and then there's no keyboard or mouse, but the bottles themselves are interfaces. There are sensors in the table below these bottles. So when I pull out a glass stopper, it signals a computer to add another instrument. What purpose are you going for here by making something like this?
Today, all the computation comes from the screen, smartphone or big iPad or notebook computers. But our group is very much interested about tangibility or tactility or physicality. So opening this bottle is so different experience than just clicking the button as a mouse.
I see. And instead of walking up to your player and pushing play, you know, on a DVD player or something like this, this makes it more, as you said, tangible and interactive and fun. Can I just do that one more time?
Sure,
just
sure,
one
please.
more, okay. Okay, what else do we have?
Usually paintbrush only paint, but this can capture the color from anything around you.
And it just replicates it.
Key idea is how to use the world as a source of the colors or inspirations, the world as a palette.
Scary. Boy, what you guys do in here late at night, I do not want to know. The Tangible Media Group's technology is more than fun to play with. Some of it gives architects and designers new tools to work with. Hi, Jim.
Hey, good to meet you, Daniel.
Daniel, nice to meet you.
This is for urban planning, this interface here. What it does is you have real building models, you can place them onto this workbench, and then they're augmented with information from virtual building models. For instance, if I rotate the time dial, we can simulate how the buildings cast a shadow. The really nice part about this interface is that it facilitates experimentation. There's also this virtual wind tunnel that we have. These are these wiggly white lines, and I can change the direction that the wind is blowing from, and I see how the buildings are affecting the wind flow. You kind of want to avoid creating wind tunnels where people's heads are blown off their heads when they exit a building.
Saves you a lot of time.
Also, you don't have to build the building first to try it out. So this project is a beautiful example of how tangible interfaces make computers more accessible to users, especially to novice users, without any instruction manual. And that way also help facilitate communication between humans, because they don't have to focus on the computer anymore.
So what do we got here?
This is Sandscape.
Sandscape? Wait, that's projected onto this.
Yeah, this one is for landscape architects.
Sandscape is an interface for designing and understanding landscapes. A camera picks up how we shape the glass beads, and a computer maps the contours of the terrain. What do you like about this the most?
So what I really like about this is you touch the pixels, you touch the bits.
So it keeps that creative inner child alive.
We want to think with our hands as humans. We're not purely in the abstract realm. People just interact differently and think differently when they think with their hands.
You think this will speed up the process and make it better, or you think it's just going to allow people to have more fun at work?
I mean, more fun is always better, but definitely allow them to experiment more, to play through more scenarios.
Just a mouse with a screen. You know, there's a disconnect there, whereas this, you feel like you're just, you're in deep. Another tangible media project that's tactile, intuitive, and playful is called Topobo. Topobo is a 3D modeling system with kinetic memory. In other words, it can remember how you move its parts and then reproduce those movements.
This is Topobo.
Say that again?
Topobo.
Topobo?
Yeah. It's a topology robot.
A topology robot.
This is a robot, but you can not only create the shape of the robot, but you can also design the motion. There's a simple kinetic memory in each module, so you can record the motion and then play it back.
Oh, look at that.
Yeah, so that's how you make it work.
So you teach it, and then it executes what you just taught it in like a half a second.
Yes.
What could be a good practical application for something like this, say out in like the real world?
Different people want to simulate like different motion, and how they communicate with it. So if they have this kind of model, they can really quickly simulate the movement or dynamic structure by just sculpting the behavior of the things, not just the shape.
So then,
Do the motion.
oops, I tore its head off.
By the way, the one more thing is I want to show you.
One more thing?
Yes.
These folks are transforming the worlds of professionals like urban planners. They're even transforming ping pong.
Would you mind playing?
No, absolutely. Wait. What did you just do to the table? All these koi
Well,
fish.
basically, there's sensors under the tables. Then sensors captures all the sound.